The night sky has always been a canvas of wonder, a vast tapestry woven with stars, planets, and secrets that whisper to those who dare to look up. But what if I told you that Earth, our lonely blue marble spinning through the cosmos, might not be as alone as we think? Not in the way you'd imagine. No, not with alien visitors or hidden worlds, but with ghostly companions, faint and fleeting, that have haunted our orbit for billions of years. They're called the Kordylewski dust clouds, or as some whisper with a shiver, Earth's ghost moons. These elusive specters, sprawling across the heavens, are said to be 9 times wider than our planet, yet so delicate, so ethereal, that they slip through the fingers of even the most determined astronomers. For decades, they've danced in the shadows of our scientific gaze, appearing to some, vanishing for others, leaving behind a trail of questions that tug at the heart of our curiosity. Are they real, these cosmic phantoms? Or are they mere tricks of light, illusions born from our longing to find something more in the darkness? I'm Alex McColgan, and today we're embarking on a journey to chase these ghost moons, to unravel a mystery that has lingered in the starlit corners of our world since 1961. So, settle in, let the night wrap around you, and let's step into the unknown. It all began with a man named Kazimierz Kordylewski, a Polish astronomer whose eyes were fixed on the heavens in a way that made the stars feel closer, more intimate. In 1961, he peered through his telescope, not at the moon or the planets, but at two peculiar patches of sky near the Earth-Moon system's Lagrange points, L4 and L5, to be precise. These aren't just random spots in space, they're cosmic havens, places where the gravitational pull of Earth and its moon balance perfectly with the forces of motion, creating invisible pockets of stability. Imagine a tightrope walker poised at the exact midpoint of their rope, neither falling nor swaying, held in place by the tension of the world around them. That's what Lagrange points are, celestial sweet spots where objects can linger, caught in a delicate dance with the universe. Kordylewski saw something there, something that didn't belong, faint cloud-like smudges, glowing ever so slightly against the inky void. He called them libration clouds, but the name that stuck was far more evocative, Kordylewski dust clouds, or KDCs. They were massive, he estimated, stretching across a region vast enough to dwarf Earth itself, yet so diffuse, so ghostly, that they seemed to taunt the very idea of discovery. The moment Kordylewski shared his findings, the astronomical world buzzed with excitement and skepticism. Other astronomers, their telescopes trained on the same coordinates, saw nothing but darkness. The clouds, if they existed, were maddeningly elusive, like trying to catch a whisper in a storm. In the 1960s, observational technology was a far cry from what we have today. Telescopes were powerful but limited, their glass lenses and photographic plates struggling to capture the faint glimmers of these supposed specters. Some astronomers managed to snap pictures, blurry and indistinct, showing patches of light where none should be. But these images were no Hubble masterpieces. They were grainy, ghostly impressions, more suggestion than proof. Newspapers couldn't even reproduce them properly, and the skeptics grew louder. Were these clouds real, or were they mirages, tricks of light scattering off cosmic dust or imperfections in the lenses? The debate raged, splitting the scientific community into believers and doubters, each side clutching their evidence like a lifeline. To understand why these clouds were so hard to pin down, we need to dive into the strange world of Lagrange points. Picture Earth and the Moon locked in their eternal orbit, a cosmic waltz that's been going on for eons. Between them lie 5 Lagrange points, named after Joseph Louis Lagrange, an 18th century mathematician who first mapped out these gravitational oases. 3 of these points, L1, L2, and L3, are unstable, like balancing a marble on the tip of a needle. Objects there, like the James Webb Space Telescope parked at L2, need constant nudging to stay in place, lest they drift away on the slightest cosmic breeze. But L4 and L5 are different. These points form equilateral triangles with Earth and the Moon, creating stable havens where objects can linger for millennia. Asteroids, dust, even tiny particles can gather here, held in place by the universe's gentle hand. It's in these stable zones that Kordylewski's clouds were said to dwell. Vast collections of dust particles, each no bigger than a grain of sand, spread across a region so immense it could swallow our planet whole. The 1960s saw a flurry of attempts to confirm Kordylewski's discovery. NASA, ever the bold explorer, sent up a Convair 990 jet laboratory in 1966, soaring 12,000 meters above the Earth to escape the city lights and peer into the void. From that lofty perch, astronomers caught glimpses of the clouds at both L4 and L5, even managing to photograph the L5 cloud, a faint ethereal glow that seemed to pulse with secrets. The Orbiting Solar Observatory, OSO6, backed up these findings, measuring the cloud's brightness and size. But the skeptics weren't convinced. In 1976, Siegfried Röser, an astronomer at the Max Planck Institute, ran numerical simulations that suggested the conditions at L4 were too chaotic for dust to linger. Solar wind, the sun's gravity, the tug of distant planets, all these forces, he argued, would scatter any dust before it could form a cloud. Radar studies around the same time found nothing, adding fuel to the doubters' fire. The ghost moons, it seemed, were slipping away again, fading into the realm of myth. Yet the mystery refused to die. In 1983, a team using a 61-centimeter telescope in Tucson, Arizona, scanned L4 and L5 and found no trace of the clouds. But just 6 years later, in 1989, Polish astronomer Maciej Winiarski reignited the spark. From an observatory in the Bieszczady Mountains, he captured the clouds in three-color photometric images, revealing something astonishing. The dust in these clouds was redder than the surrounding space dust, hinting at a unique composition. Where was this dust coming from? Was it ancient, born in the fiery crucible of the solar system's formation, or something more recent, swept up from the cosmic winds? Winiarski's photos were a lifeline for the believers, but the skeptics struck back in 1991 when Japan's heightened space probe looped through L4 and L5 and detected no dust at all. The probe's single pass, however, was too brief, too fleeting to catch the slow-moving particles, and astronomers cautioned against dismissing the clouds outright. The ghost moons were playing a cosmic game of hide-and-seek, and humanity was struggling to keep up. What makes this story so gripping isn't just the science, it's the human longing behind it. Each glimpse of these clouds, each photograph or measurement, was a moment of triumph, a fleeting connection to something vast and unknowable. Yet every failure to find them, every empty scan of the sky, was a reminder of how much we still don't understand about our own cosmic backyard. The Kordylewski dust clouds, if real, are a testament to the universe's ability to surprise us, to hide its wonders in plain sight. They're not solid moons or asteroids, but vast, shimmering veils of dust, each particle catching the sunlight just enough to whisper its presence. And as the decades passed, the question lingered. Why could some see them while others saw nothing? The answer, it seems, lies in the clouds themselves, fragile, dynamic, and ever-changing, like ghosts that appear only to those who know where to look. The hunt for Earth's ghost moons is a story of persistence, of astronomers refusing to let go of a mystery that seemed to slip through their fingers like stardust. As the decades rolled on from Kordylewski's first sighting in 1961, the Kordylewski dust clouds, those elusive specters lurking in the Lagrange points, remained a cosmic enigma, a puzzle that teased the edges of human understanding. Each fleeting glimpse of these clouds felt like a heartbeat in the vast silence of space, a reminder that the universe is alive with secrets we're only beginning to touch. By the 1990s, the debate had become a tug-of-war between hope and doubt, with some astronomers clinging to grainy photographs and others dismissing them as cosmic mirages. But the story wasn't over. Far from it. The ghost moons were waiting, shimmering in the dark, ready to reveal themselves to those patient enough to keep looking. And in 2018, a breakthrough would come that would shift the tide, pulling us closer to the truth than ever before. Imagine the frustration of those early astronomers, their eyes strained against the night, searching for something that seemed to defy capture. The Kordylewski dust clouds, or KDCs, were not like the moon, solid and dependable, hanging in the sky for all to see. These were veils of dust, so fine and sparse that they were nearly invisible, stretching across a region 100,000 kilometers wide, yet weighing almost nothing. Picture a fog so thin you could walk through it without noticing, yet vast enough to blanket a continent. That's what these clouds were: delicate, diffuse, and maddeningly hard to pin down. Their particles, some as small as a micron, the size of a single bacterium, danced in the gravitational embrace of L4 and L5, those stable Lagrange points where Earth and Moon hold sway. But the universe is not a gentle place. Solar wind, the relentless breath of the sun, could scatter these particles. The gravitational tug of distant planets could nudge them out of place, and the moon itself, with its subtle shifts, Mazarenia, could disrupt the delicate balance that kept these clouds together. It was no wonder, then, that some saw them while others saw only emptiness. In the 1990s, the skeptics held the upper hand. The Japanese Heightened probe's failure to detect dust in 1991 had cast a long shadow, and many astronomers began to wonder if the clouds were nothing more than wishful thinking. But the believers, those who felt the pull of the unknown, kept searching. They knew that the universe loves to play tricks, hiding its treasures in the flicker of light or the shadow of doubt. And so they turned to new tools, new ways of seeing. By the early 2000s, technology had begun to catch up with human curiosity. Telescopes grew sharper, cameras more sensitive, and computers more powerful, able to sift through data that would have overwhelmed earlier generations. Astronomers started to experiment with techniques like polarimetric imaging, a method that captures light in a way that reveals its hidden properties. When sunlight hits dust particles, it scatters, bending and twisting in ways that depend on the particle's size, shape, and composition. By filtering this light through special lenses, scientists could tease out patterns that the naked eye, or even the best telescopes of the 1960s, could never see. It was in this spirit of relentless pursuit that Judith Slice-Balog, Gabor Horváth, and András Barta, a trio of Hungarian scientists, stepped into the fray in 2004-2018. Armed with cutting-edge polarimetric imaging, they turned their gaze to the L5 Lagrange point, that cosmic haven where Kordylewski's clouds were said to linger. Night after night, they collected images, each one a snapshot of light bouncing off invisible grains of dust. What they found was breathtaking: patterns of polarized light that matched exactly what you'd expect from a vast, sprawling cloud of dust particles. The light wasn't random, it was structured, organized, as if the universe had painted a portrait of its own secrets. In their 2018 paper, the team declared that these patterns could only come from dust. Nothing else could explain the way the light danced. It was a moment of triumph, a vindication of Kordylewski's vision from nearly 6 decades earlier. The ghost moons were real, or at least the one at L5 was. The scientific world took notice, and the skeptics, for the first time in decades, began to falter. But the story doesn't end with a single discovery. The universe is never that simple. Slice-Balog and her team didn't just rely on images. They turned to the power of simulation to understand how these clouds could exist. They modeled the motion of 1.86 million dust particles, letting computers trace their paths through the gravitational tides of the Earth-Moon system. What they found was astonishing. Under the right conditions, dust could indeed gather at L5, forming clouds that mirrored the size and shape of what they'd seen in their images. These weren't static structures, frozen in time like the pyramids. They were dynamic, ever-shifting, like a sandstorm caught in a cosmic whirlpool. The simulations suggested that the clouds could persist for long periods, their particles trapped in the gravitational embrace of L5, but they weren't permanent. Solar wind, planetary perturbations, even the moon's own orbit could disrupt them, scattering the dust only for it to reform later, like a ghost that fades at dawn and reappears at dusk. This dynamic nature might explain why the clouds were so hard to find. Imagine trying to photograph a flock of birds in mid-flight, their shapes shifting with every gust of wind. Some nights the clouds might be dense enough to catch the light, glowing faintly against the void. Other nights they might thin out, their particles too sparse to register. The moon's orbit, which shifts slightly over time, could change the density of these clouds, making them more or less visible depending on when and where you looked. It was a revelation that felt both humbling and exhilarating. The ghost moons weren't just hiding, they were alive, breathing with the rhythm of the cosmos. This idea that the clouds could form, disperse, and reform gave new life to the decades-old debate. It wasn't that Kordylewski or Winiarski or the NASA jets had been wrong, it was that the clouds themselves were elusive by nature, a cosmic phenomenon that refused to be pinned down. What makes the Kordylewski dust clouds so captivating is their fragility, their impermanence. They're not solid like the moon, not even as tangible as an asteroid. They're made of particles so small they'd slip through your fingers, yet they stretch across a region so vast it defies comprehension. To stand on Earth and know that these clouds are out there, invisible to the naked eye, is to feel a connection to something ancient, something that's been part of our planet's story since the dawn of the solar system. These clouds might be billions of years old, their dust born in the fiery chaos of the universe's youth. Or they might be younger, swept up from the debris of passing comets or the slow erosion of the moon itself. Their reddish hue, noted by Winiarski in 1989, hints at a composition unlike the ordinary dust that floats through space. Could they be remnants of some long-forgotten cataclysm, or are they constantly replenished, a cosmic cycle of loss and renewal? The questions are as endless as the stars, and each one pulls us deeper into the mystery. As we stand on the cusp of 2025, the Kordylewski dust clouds remain a testament to the power of human curiosity. They remind us that even in our own backyard, the universe holds secrets that challenge our understanding. The breakthrough in 2018 didn't end the debate. It opened new doors. Scientists are now asking how these clouds affect space weather, how they interact with satellites, and whether they could hold clues to the solar system's past. The L4 cloud, less studied than its L5 counterpart, beckons for further exploration. New missions, armed with radar and even more advanced imaging, could finally map these clouds in detail, revealing their structure and their story. But for now, the ghost moons remain just that. Ghosts, shimmering at the edge of our vision, daring us to keep chasing. As we stand beneath the stars in 2025, the Kordylewski dust clouds, Earth's elusive ghost moons, continue to haunt our imagination. Their faint glow a reminder that the universe is never done surprising us. These cosmic specters, drifting in the stable Lagrange points of our Earth-Moon system, are more than just clouds of dust. They're a bridge to the ancient past, a whisper of the forces that shaped our world billions of years ago. They're not the solid, dependable moons we're used to, nor are they fleeting visitors like the mini-moons that briefly grace our orbit. They are something else entirely, dynamic, ever-changing, and maddeningly hard to grasp. The journey to understand them has been a testament to human tenacity, a decades-long chase through the darkness, fueled by equal parts wonder and doubt. With each new discovery, from Kordylewski's first sighting to the polarized light revelations of 2018, we've inched closer to unraveling their mystery. But the ghost moons still hold secrets, and their story is far from over. They beckon us to keep looking, to keep questioning, to keep dreaming of what lies just beyond our reach. What makes these clouds so extraordinary is their delicate dance with the cosmos. Spanning regions vast enough to swallow Earth 9 times over, they're made of particles so tiny, a micron or less, smaller than a grain of pollen, that they are invisible to the naked eye. Yet when sunlight catches them just right, they shimmer, a faint glow that feels like a secret shared between the universe and those who seek it. The 2018 breakthrough by Judith Sleesbalok and her team showed us that these clouds are real. They're polarized light patterns, a cosmic fingerprint that can't be faked. But even this triumph left questions dangling like stars in the void. Are these clouds permanent residents of L4 and L5, or do they come and go, dissolving and reforming with the rhythms of the moon's orbit? The simulations suggest they're dynamic. They're particles caught in a cycle of loss and renewal, like a river that never stops flowing. Solar wind, the gravitational pull of distant planets, even the subtle wobble of our moon, all these forces tug at the clouds, reshaping them, scattering them, only for them to gather again in the quiet embrace of the Lagrange points. This impermanence is what makes the ghost moons so haunting. They're not fixed, unchanging landmarks like the craters on our moon or the rings of Saturn. They're alive in a way, their structure shifting with the cosmic tides. To picture them, imagine a veil of mist stretched across the sky, so thin you could see the stars through it, yet vast enough to cover a world. Some nights the clouds might gather thickly, their particles dense enough to catch the sun's light and glow faintly against the dark. Other nights they might thin to nothing, their presence felt only in the absence, a ghost that slips away before you can be sure it was there. This ebb and flow could explain why astronomers like Kordylewski and Winiarski saw them while others, peering through equally powerful telescopes, saw only emptiness. It's a reminder that the universe doesn't always reveal itself on our terms. Sometimes it demands patience, persistence, and a willingness to see what others overlook. But the Kordylewski dust clouds are more than a scientific puzzle. They're a mirror to our own curiosity. For over 6 decades, astronomers have chased them, driven by the same longing that makes us gaze at the stars and wonder what's out there. Each photograph, each measurement is a small victory, a moment when humanity touches the infinite. Yet the failures, the empty scans, the negative radar results, are just as important. They remind us that the universe is vast, complex, and not easily tamed. The cloud's reddish hue, noted in those 1989 images, hints at a story we've yet to fully tell. Is their dust a relic of the solar system's birth, forged in the fires of ancient collisions? Or is it newer, swept up from passing comets, or chipped away from the moon's weathered surface? These questions pull at us, urging us to look closer, to send new probes, to build better instruments, to map the cloud's shifting shapes with the precision of a poet tracing the outline of a dream. As we look to the future, the ghost moons offer a challenge and a promise. The L4 cloud, less studied than its L5 counterpart, remains a frontier waiting to be explored. New technologies, like advanced radar systems or next-generation telescopes, could reveal details we've missed, mapping the cloud's structure with a clarity that Kordylewski could only have dreamed of. Scientists are already asking how these clouds might affect space weather, their tiny particles interacting with solar radiation in ways that could ripple through our satellite networks. Could they pose a risk to spacecraft, their micron-sized grains wearing down delicate instruments over time? Or might they hold clues to the solar system's history, their composition a record of events long forgotten? In 2025, with private space companies and international agencies pushing the boundaries of exploration, the Kordylewski dust clouds are no longer just a curiosity. They're a call to action, a chance to deepen our understanding of the cosmic neighborhood we call home. These clouds also remind us that Earth is no stranger to unusual companions. Mini-moons like 2020 CD3 have come and gone. Tiny asteroids briefly caught in our orbit before spinning back into the void. Quasi-moons, asteroids that dance with Earth around the sun, mimic the behavior of true moons from certain angles. But the Kordylewski dust clouds are different. They're not solid objects, not temporary visitors. They're a feature of the Earth-Moon system itself, potentially as old as the system's formation, a ghostly presence that's been with us since the beginning. Unlike mini-moons, which vanish within a year, or quasi-moons, which belong more to the sun than to us, the KDCs are a long-term part of our story. They're a reminder that even in our own backyard, the universe holds wonders that defy easy categorization, wonders that feel almost otherworldly in their strangeness. As we close this chapter of the Ghost Moon's tale, we're left with a sense of awe and possibility. The Kordylewski dust clouds are a testament to the universe's ability to hide in plain sight, to weave mysteries that challenge our best minds and most advanced tools. They're a call to keep exploring, to keep questioning, to keep chasing the faint glimmers that hint at something more. In 2025, as we send new missions to the Moon, Mars, and beyond, the ghost moons remind us to look closer to home, to the quiet corners of our orbit where secrets still linger. They're a reminder that the universe is not just out there, in the distant galaxies or uncharted stars, but right here, in the delicate dance of dust that shares our journey around the sun. So the next time you look up at the night sky, imagine those invisible clouds, vast and fleeting, shimmering in the dark. They're out there, Earth's ghost moons, whispering their story to anyone who dares to listen.